Lesson 46, simplifying expressions with square roots and higher order roots. So example 1 says to simplify each expression. So you should know, I didn't change my, just a second. Lesson 46, simplifying expressions with square roots and higher order roots. Example 1 says to simplify each expression. You should know the symbol that we show here as the square root symbol. Okay, you should know that. And the square root means what times itself is going to get me 81. Well, you should know all of these across here. So what times itself gets me 81? That will be 9 times 9. So my answer to this one is just 9. That's the square root, because 9 squared gives me 81. On B, they say negative square root of 16. That means my answer is going to be negative, and then the square root of 16 is what times itself gives me 16, and that would be 4, because 4 times 4 equals 16. On 1, the square root of 1, 1 times 1 gives me 1, so 1 is the square root of 1. D is the tricky one. I want you to think about that one for a second and see what you think the answer is, and write it down on your paper. There are a couple of different things that you could have guessed. You could have either guessed 3, or you could have guessed negative 3. Well, 3 is the square root of 9, because 3 times 3 gives us 9, but negative 3 times negative 3 also gives us 9, because a negative times a negative gives me a positive. So this one we cannot do. There's no solution. So we would just say no solution. And my pen's not working once again today. You all are probably used to that by now, so I apologize for the poor writing. Higher order roots. If a to the n equals b, then the nth root of b is a, or the nth root of b equals a. So this is how we write that, the nth root. Okay, normally we say the square root. Well, you should know that the exponent of 2 means square, and so it's an understood 2 out here whenever we don't see an index. N is what we call the index. When we don't see one, it's an understood 2. But we could put higher order numbers there and to deal with higher order roots. So for example, on example 2, we have an index of 3 here. So what they're wanting is the cube root of 125, or the third root of 125. And what this means is what times itself, excuse me, what times itself 3 times is going to give me 125. Well, the answer to that is 5. Because 5 times 5 times 5 will give me 125. So that shows me that 5 times itself 3 times is 125. So the cube root of 125 is 5. On D, we want to know the cube root of negative 1000. Well, this is another one where they're trying to trick you, because we just said that negative 9 had no solution for the square root of negative 9. But on this one, we're actually talking about the cube root. And because it's a negative, that can happen, because negative times a negative gives me a positive, times a negative brings me back to a negative. So in this case, my answer is going to be negative 10. Because negative 10 times a negative 10 times a negative 10, excuse me, negative and a negative gives me a positive, which I get 100 from this, but 100 times the negative 10 gives me a negative 1000. So that's where I get my answer from. On C, we're wanting the fourth root here, and the fourth root is what times itself 4 times is going to get me the answer. I want you to try C and D. D is asking for the fourth root of negative 81 on your own paper. Go. On C, the number times itself 4 times that gets us 16 is 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. D is another one of those tricky ones. But what you need to remember is that we said up here that the 3 would work. Do you know why the 3 would work? Because it's odd, and an odd number of negative numbers multiplied is going to give us a negative number. But I can't ever get an even number of negative numbers multiplied to give me a negative number. So if I have a negative times a negative times a negative times a negative, well, these double negatives give me a positive, and these double negatives give me a positive, and a positive times a positive gives me a positive, which means that this one has no solution. Fractional exponents, if I have the nth root of b, I could also write that as a fraction by writing it as 1 over that index. So, for example, this one we say as the square root, the square root of x, which I can write as x to the 1/2 power because we said that there's an understood 2 out here. We just don't show it. On 3, or the cubed root of x, we can write that as x to the 1/3 because the 3 is the index and I just put 1 over that index, which is exactly what they've done here. So on these, again, I didn't say before, but you can always plug these right into your calculator and get yourself a nice quick answer. But this one is actually asking us for the cube root of 343, and you can punch that in either way. It doesn't really matter. So if I ask for So you can put that in either way, it doesn't matter. And what that's going to get you is an answer of 7, because 7 times itself 3 times is going to get you 343. Same thing on this one. I have a negative, but this is an odd, which means that it could be possible. So what times itself 3 times is going to get me a negative 8? That's going to be negative 2. Negative 2 times negative 2 is a positive 4. Positive 4 times negative 2 takes me back to that negative 8. On C, they're wanting the 4th root, which means something times itself 4 times. You can punch that into your calculator and find the answer is 5. Now, if you do not have a calculator with you, you're probably just following along with what I say. But if you do have a calculator with you, make sure that you're practicing plugging these in and getting the same answers, because sometimes, especially if we're dealing with fractional exponents, we don't punch things in exactly the right way, and then it can ruin our answer. So make sure that you know how to use your calculator to do these, because these should be give me points whenever you see it on a test. You should never ever miss one of these because your calculator will do all of it for you. Now on D, we have negative 1,296 to the 1/4 power. This is not going to work because this is a negative and this is an even, and I can never get an even number of negative multiples to end up being a negative. Negative times a negative is a positive, times a negative is a negative, and times a negative is a positive. So this one has no solution. Okay, last example here. It says a box has a volume of 6,859 cubic inches. What is the length of the side of the box? So I have the volume and I want to know the length. So I have a box, okay, and this box, which they don't actually say, but this box is a cube, and there's something important that we need to know about a cube in order for us to be able to solve this problem, and that is that the length, the width, and the height are all the same length. So I know that the length is x, the width is x, and the height is x because they're all the same, and when they're all the same I want to use the same variable. So I just said that the volume is equal to, and it is that length times width times height. Well, we now know that it's a cube, so it's going to be equals x times x times x, which is the same as saying that the volume is equal to x to the first times x to the first times x to the first gives me x to the third, or x cubed. And they've given me the volume, so I could plug that in. 6,859, and that's cubic inches, is equal to x cubed. Well, to cancel a cube is very similar as canceling a square. Whenever we have a square, we say we want to do the opposite, and the opposite of squaring is square rooting. So the opposite of cubing would be cube rooting. So I'm going to take the cube root of both sides of that equal sign, because what I do to one side I must always do to the other. So all I have to do is find the cube root of 6,859, which I don't know off the top of my head, and that is 19. So x is equal to, because those canceled, okay, and it is going to be 19 inches. And that's my final answer. So that's all I have for you tonight. Please make sure that you've taken good notes, and I'll see you in class tomorrow.